Today's speakers may be familiar to some of you. Cheryl Jones and James Doswell presented the 2019 Best Paper overall for us at the ICO workshop in Tampa on the results of their software sustainment cost estimation for the Army. Today, Cheryl is back, and she's got Brad Clark here with us to talk about improving software estimation relations for Army software sustainment data. Cheryl?
Thank you. Okay, so as was just mentioned, we presented this information on our software sustainment work last year. We've done some additional work this year that I want to talk about. And if I go to the presentation overview, there's two main changes we've made to the analysis for this year's presentation. We did annualized analysis of the data. So in the past, we collected data on the releases, and the releases can go anywhere from 3 months to 3 years. And we did the analysis based on the full releases. In actual fact, most of our programs are OMA-funded projects in software sustainment, and they get annual data. So we've converted the data into annual data and looked at what they accomplished in any given year. Just a quick bottom line up front, we didn't find significant differences when we did this. And it's a lot easier for people to provide data annually, since that's the way they're funded, that's the way they're tracked. So this is the way we'll be doing the analysis going forward, but I'm going to show you some of those results. And then the other thing we did was an analysis of causal relationships. So the SEI has been doing some work on causal analysis and looking at how do we figure out what factors are important. And in fact, when we did the questionnaire to collect our data, we collected data on a whole bunch of factors that we thought might affect software sustainment, but we weren't really sure what the right answer was in terms of what was important. And so the causal analysis attempted to look at the data we collected and really, from a quantitative standpoint, identify those CERs, those relationships that are important. And it helped us to winnow down the analysis and to come up with some interesting kinds of ways of looking at the data. So I'm going to show you, those are the two main things we're going to talk about today. All right, so first let's just give you a little background on the software initiatives. What we were trying to do, what we are trying to do and continue to try to do is to collect data on software sustainment for the Army across all the programs doing software sustainment. And, oops, I went forward to, oops, sorry, I'm supposed to be on this slide. On all the Army programs, and come up with better ways to estimate them. When we started the project, we were basically estimating as a flat rate level of effort kind of activity. So we wanted to come up with CERs that better represented software sustainment. We have done that. We have generated CERs. They're being used today by DASA CE, who are the folks that do the independent government cost estimates. And we've shared them through the community, through presentations at ICEA, the papers we've done, which are all publicly available for your use today. What we're trying to work on now is sort of making this data collection a lot more systemic and a lot more institutionalized. So we're moving to data collection via the SRDRM as that comes online and gets used in the future. Hopefully we'll be collecting all of the data that way. Right now we're still collecting via questionnaires, and then improving policy and the technical requirements to match all that. So really what we're trying to do is to have a database of good data on software sustainment to inform decisions and make that data available to organizations and people for their use. So some of our accomplishments, we have developed this questionnaire. The questionnaire was then the basis for the SRDRM. So we have a way of collecting data. As part of that, we developed a WBS, which I'll show you in just a minute, that collects the major costs for sustainment. And we're moving to annual collection, although again, still by questionnaire today. We do have a comprehensive database. There's 192 systems in the database. There's over 700 capability releases, either enhancements and new functionality or bug fixing maintenance releases. And there's another 300 releases that are addressing security issues, what we call IAVA releases. And there's about 3,200 records on software license data and what it cost. So there's a pretty robust repository which we've used in the third bullet to make fact-based decisions. We've done some significant analysis. We're using it in-house to do the cost estimating at CCEA, but we're also using it to answer questions that come up with senior leadership in the Army. And we're making all the data and the analysis results available to the community for their use. This is the WBS that we're talking about. 8 major efforts or 8 major activities that go into software sustainment. One of the things we found was that a lot of our senior management thought of software sustainment as WBS element number 1, which is changing the code. While that's important, and obviously that's where we want to get to, the reality is that that's only a small portion of the cost for software sustainment. There's also things like the licenses that you have to pay for every year, whether you change a single line of code or not. The certification and accreditations, which again have to happen anytime you do a release and on regular basis. There's facilities you got to have. And some of the interesting analysis we reported on in past years was when you look at this, a lot of these costs are fixed costs. You have to buy licenses and have management and do your CNAs, whether or not you change a line of code or not. So if you cut cost in sustainment, say 10%, what you may be changing is all of the money that goes to actually changing the code. Or you may be changing a 10% cut across the board for the program may result in a 40% cut in what you can actually change in the code because the fixed costs don't go down every year. This year we had done some updates to the WBS. WBS 1 we separated into the cost for the capability changes versus the security fixes. And then in WBS 6 we separated out the cost for the help desk and the hosting separately from the engineering and user support. Definition of software sustainment. Basically, the thing to know about our definition is we start software sustainment as soon as the first release is released to somewhere, whether that's to testing, whether that's to a demo, whether that's to the field. As soon as the first release is out there, it has to be sustained. At a minimum, you have to make any cyber security updates that are required, and there may be other things as well. So our definition of sustainment starts as soon as the first release happens, which in many cases may be pretty closely after milestone C. So it includes not only the OMA-funded activities that are done at the Army sustainment organizations, but it also includes the production money done by the program management offices during the production phase of the contracts. Some demographics on our data. So as you can see, 192 systems, 93 of them are real-time systems, and then a smattering across the other application domains we looked at, engineering, AIS support, and then there's a few defense business systems that we pulled out separately because of the size and complexity of those. On the right-hand side, the aging, some of these systems have been in the field for upwards of 40 years. The left-hand side of this chart is the PDSS, which is the ones done by the program offices, which is either RDT&E or production funding. The right-hand side is the PPSS, which is the OMA funded at the software sustainment centers. On the bottom left, the releases by change type. You can see there's over 1,000 releases. They're split between the capability releases on the top are split between maintenance and enhancement. So maintenance is the bug fixing, enhancements are new functionality. And then there's a set of hybrid ones which have a significant amount of both of those. And then there's the cyber releases, which are fixing the security issues. Right-hand side, the size measure. One of the things we did was we asked for size in 6 different ways because we weren't sure what was going to be the best size measure for sustainment. software changes was the one measure that was most often used by the programs. It's also the measure that gave us the best correlations when we did the CERs. So that's the main measure we're going forward with, although we're also continuing to look at IEVAs and requirements in certain circumstances. Not a lot of agile data in this data set. We're starting to see a little bit more in the more recent data, but we're not switching over as quickly as it's taking a while to do the switch over, I guess I should say. All right, so let's talk about the annualized data. So WBS elements 2 through 8 were collected for each fiscal year. The capability data we collected by release originally. And so start and end dates span multiple years, and I'll show you a slide on that in just a minute. We've taken that multi-year data and separated it out into the individual years. And then we did the additional analysis on the CERs for that and compared it to the data, the results we got when we did it for the full release. And the benefits, again, it's compatible with the other WBS elements. It's going to simplify data collection and make it easier for those providing us data, and it matches our funding cycles. All right, this slide shows the release duration for the programs that we have in the data set, or the releases rather. And you can see that there's a block of programs that are in the 0 to 6 months range. In fact, the median is right at 6 months. But then there are a group of programs in the red box that are more than 12 months in duration. So they cross multiple years and are funded over multiple years. If we take the data and annualize it, do the first CER on all the data set, obviously the R-squared here is not very good. It's 37%. Definitely not a CER that could be used. So the first strategy we employed to reduce the variability was to do some trimming of the upper and lower 10% of the data based on total cost. And then we segmented it into the various categories that we identified as being important. So super domain, acquisition level, and then commodities. So if just with the trim data, you can see a pretty significant improvement in the R-squared. We went from, 37% to 63%, so we're already getting better data. Some of the assumptions on how we trimmed it, we removed ones with missing data or no dependent variable. We got rid of the DBS ones. The ACATs we split into 3 blocks, the ACAT 1, ACAT 2, and then everything else, which is 3, 4, and the non-programs of records. And we used R-squared as our base analysis. So in this chart, you can see in column 4 is the R-squared from doing this analysis. And you can see simply by looking at the R-squared in column 4 that by breaking it out by either application domain or commodity and trying different measures of size, whether it's the software changes or the requirements, we have improved R-squareds. And if you look at column 6 was the R-squared we had from the original analysis we did, where we looked at releases regardless of how long they were. And in most cases, the R-squared, by annualizing it, is a little bit better. There were a couple that were on the bottom 2 rows that were slightly less, but overall fairly equivalent in terms of the R-squareds we saw from looking at the data with the annualized analysis.
Cheryl?
Yes.
One thing I would add is that far right column, Prev R-squared, was the data, these CERs done on the the full release data that was not annualized. So you can kind of compare the full release data compared to the annualized release data, which is previous R² to adjusted R². So you can see the improvement if there is any.
Yep. And for example, in the commodity block, the big block in the middle, we went from R² of 0.68 to one of 0.7. So a slight improvement on the R². On the next chart, we have the new data. And in this one, we looked at it a little bit differently. We separated, so the first couple of boxes treated the ACAT level and the application domain as a dummy variable. And so what is the word I'm looking for? Sorry. The exponent, thank you. The exponent is the same in each of those equations, but the intercept is a little bit different. Then we also separated it out in row 4, 5, 6, and 7, where we separated out by the individual ACAT levels and application domain. And in general, that gave us better R² than looking at it as a dummy variable. And especially for particular groups. So you can see that the ACAT one in real time, for example, had a pretty good R² versus the one for engineering had a much lower one. So this allowed us to separate out the blocks, if you will, that had good R² and good commonality in the data that were provided. Versus those that had some more variation in them. And as we look at this data, you can see that several of these equations are getting in the better than 80% range, which says that they're pretty good R² and certainly usable for doing cost estimates and being, I guess, trustworthy and worth using. And then this is a follow-on set of those. And again, we looked at these for the different application domains, the different ACAT levels, and have equations for all of these. Basic conclusions on the annualized data. The annualized data is not a whole lot different than the performance of the CERs for the multi-release data. And so we think this is worth using and going forward with, and that's what the plan is. We have done the conversion so we can combine the old and new data sets to continue this analysis this way. And I talked already about the different exponents, but same exponent, different constant versus the new way where we allow both of those to vary, and we got some improved R² on doing that. Okay, I'm going to talk a little bit now about the causal analysis. So the causal analysis, we were looking for, again, those factors that really influence the CERs. And we want to separate it out, the correlation versus the causation. And the example that we've used a lot is ice cream sales are correlated with shark attacks. So if you did a basic CER on those two factors, you would find that there's a pretty high R² between those two in an equation using those two factors. But in fact, neither one of those causes the other. There's a third confounding variable, or not even confounding variable, just another influencing variables that affects both of them, and that's weather. So when the weather's nicer, people go to the beach, they eat more ice cream, and there happen to be more shark attacks. So there's correlation between them, but there's not causation. And so with the causal analysis, we're trying to look for those factors that have causation. And in the example on the bottom of the screen, you can see that factor, if I just look at the top part of the diagram, factor X1 has a causative relationship with y. Factor x2 has a causative relationship with both x1 and with y. So if we use both of those factors, x2 then is double counted, if you will, because it not only has an impact by itself, but it also brings in the impact of on x1. So we're double counting. So that might be a confounding variable. Likewise, in the bottom of the diagram, if we look at y and we look at x1, x6, and x5, all have an impact on y, but x6 also impacts x5. And so if we include all of those variables in there, again, we're double counting the variable x6. And so we'd want to use only 2 of the 4 factors when we're looking at y. Brad, do you want to add anything else on that one?
That's right. When X2 influences another variable, it's multicollinearity. It's always a problem that you look for when you try to create these CERs. And this technique that the Software Engineering Institute has helped us look into all this data that we were collecting to see which ones were the real predictors of our variable of interest, which was the effort to do a change.
And as Brad said, we did this in conjunction with the folks at the Mike Conrad, Bill Nichols, and Bob Stoddard helped us with this. We looked at all of the factors that we had included in the database, and we did a bunch of analysis on this. And basically, once we did all the analysis, we came down to superdomain and ACAT level being the main tiers that we did, and then we looked for within each superdomain and each ACAT level, we looked for the factors that had a causal impact on data. Unit cost was the Y variable that we looked at, and one of the interesting things was different groups had different predictors for the CERs. And so I'm going to show you the diagram for all of the factors for the different groups, but then we're going to just show you the presentations for the real-time ACAT levels as an example of this. So this chart is the influencing factors. And you can see the 3, ACAT 1, ACAT 2, and then ACAT 3 and lower across the top of the diagram. Across the left-hand column, we have the superdomains, real-time engineering and AIS. These are the 3 domains that we had enough information to do an analysis of. And you can see that the bullets in each block are different for each block. And some of the blocks didn't have enough data and enough variables to allow us to do this causal analysis. But if we look at the top left block, which was the ACAT 1 real-time, we can see that phase, inter-service partner count, and hardware platforms were 3 factors that causally influenced the cost. Phase is fairly straightforward, as is hardware platforms. Inter-service partner counts is a count of the number of DoD services or organizations that are involved in a program. So most of them had Army, because this is Army data. But if you were also involved with the Navy or the Air Force or a foreign military partner, then your count would be higher. And what we found was the inter-service partner count, the more organizations involved, the more the cost was. And that kind of makes sense, because if you've got more partners, then you have more people affecting requirements and changing requirements, and you also have more people that you have to communicate and deal with, which obviously increases cost. So if we take that first block and we look at that a little more detail, this is the chart for the ACAT 1 data for real time, and you can see there's 3 red arrows of causal factors: the phase, the service count, and the hardware platforms. And you can see the equations here. And again, we got pretty good RSquared if we look at the service count, which is the third block down in the table below, you see we had an R-squared of 0.84, which is pretty good for cost estimating. One of the interesting things is on the last row of here, when we included both service count and hardware platforms, we didn't get any improvement in the R-squared. So even though they're both causal factors, using both of them didn't improve the equations. And when we used both of them, we also had high p-values. So the service count is the equation that we would use from this set of analysis for real-time ACAT-1 programs. For ACAT-2, slightly different equations. The R-squared that we had was not quite as good as the last one, but it was still 0.75, which is not bad. And even though service count is impacts it, it didn't improve the R-squared in this case. ACAT-3 and below, there were 3 factors, the hardware variance, the phase, and then in this one, the software size in lines of code, the baseline size had an impact. And the R-squared's not quite as good here. 0.71 is as high as we got on this one. So conclusions from the causal analysis, it did provide insight into which factors were important and which independent variables should be examined. It saved a lot of random analysis time. Before we did this, we were doing 101,001 different equations to try to figure out the factors that were important. So this let us narrow in and focus on those factors that were identified as important. It also helped us to, in the third bullet, to look at which data is really important for CERs and which can be eliminated from data collection, which will simplify the questionnaires. In general, the segmenting the data showed that was a good idea. The more we segmented into the ACAT levels and the application domains, the better the equations we got, rather than trying to do one-size-fits-all CERs. And that also highlighted some areas where the data was not very consistent. So we thought this was useful and provided some good data and helped us, and we definitely recommend it for folks that are considering analysis going forward. Brad, anything else you want to say about causal analysis?
Oh, just I know the SEI guys that helped us. They're very much of the belief of the last bullet that before you do regression analysis, you should do causal analysis to make sure that you are truly identifying causal relationships and not things that are influenced by confounding variables. That's kind of the takeaway.
Yep. So next steps, we're going to continue the annual collection. We have the set of data from FY18. We're working now on processing. We're talking about data repository and data storage going forward and how this is going to work. SRDRM is out there now. It's starting to be used on programs. As we go forward and more data comes in that way, that'll become the basis for any future analysis, but it's going to take us a while to get the existing programs converted to using that form and providing that data in a useful manner. And so for the next couple of years, we'll do the questionnaires. And we're going to continue to look at the benchmarks and the estimating relationships. And we're updating our analysis based on the CERs. We're updating the CERs based on the causal analysis and some of the insights that we have collected. And that's it. Anybody have any questions?
We have not gotten any questions through the question box just yet, but we'll give everybody a chance to send them. We'll talk for just a moment. You'll notice everybody's contact information is up on the slide you're seeing right now. We also want to remind you that the deadline for sending in your abstracts for the 2021 ICEA workshop is coming up on November 3rd. So if you want to present a paper like this one to your colleagues at the ICEA workshop in this coming May, send us your abstract and we'll give it a look and consider it among the rest. And I'm stalling.
Megan, do you have a location yet for next year's conference? I'm anticipating that we'll be able to go in person.
I certainly hope we can. It's going to be in Minneapolis at this hotel that is one of the coolest I've ever seen in my life. It's the Renaissance Depot. It's built sort of as an addition to a train station that was built in the 1890s. So the whole hotel is railroad and Art Deco themed. It's very, very cool. Okay, we've got that worked. We've got a question. Let's see. John McGann, get yourself ready. I'm going to unmute you just a moment. Unmute yourself whenever you're ready, John, and we'll get you. You're on.
Yeah, hi. First of all, double check, can you hear me?
We can.
Perfect, okay. It was mentioned, I think it was someone maybe mentioned an SCI tool or a technique related to the identification of the causal relationships. Can a little bit more information be provided on that in terms of what is this tool? What is this technique? You talked about applying a tool, but you didn't give any information about it.
All right, Brad, you want to talk about the tool a little bit?
Yeah, sure. The tool is called Tetrad, T-E-T-R-A-D. You can look it up in a search engine. It's a free tool. It's available. CMU is the university that offers it. There are tutorials on causal analysis using the tool. It is a Java archive file, a jar file. So you have to have a Java runtime on your system. But what's nice is I use a Mac. I think Cheryl uses a PC. You can double click on the jar file and it runs the same on both. Yeah, and then to run the tool, you would want to watch a few tutorials on how to load the data in the tool. And then there are different causal search algorithms that are available. And the SEI guys use a number of these to tease out what the relationships were. And often it was a consensus kind of thing. You'd use different search algorithms and you would observe what's coming up most frequently, that kind of thing. So Tetrad's the name of the tool. Let's see.
And Megan, I think they did a paper on that. Was that one of the papers being offered?
Tetrad doesn't ring a bell for me, but unless it has a different name.
It would have it would just talk about causal analysis. Mike Conrad or Bill Nichols or Bob Stoddard would have been the names on it.
Okay. Well, we've got a website someone just posted in the questions, the website for Tetrad, and actually I will copy that and put it up. I'm going to take control of the screen if you don't mind.
Okay. In any case, if there's not an ICEA presentation, they definitely have some papers and presentations available on that. So we can certainly shoot me an email if you, and we can give you their contact information.
Yes, absolutely.
Yeah.
And if you go to the ICEA archives, it's ICEAonline.com/archives. There's also a button for papers library at the top of the ICEA website. You'll be able to search those archives when you have a moment.
Yeah, and by the way, that was marvelously answered. I think the name of the tool and the Google search probably would have got me a lot, but really appreciate the depth of the response. So thank you very much. That was all I had.
There we go. There's that website for you. And thank you to our viewer who sent that to us. So I'm going to one more time give a little plug for the ICO workshop next year. The abstract deadline is in probably about 60 days, maybe at this point, a little more than that. So get writing, get thinking. Take a look at the ICO archives for the kinds of papers that folks have written in the past if you need an idea on the format or however else other sort of inspiration might get you. Cheryl and Brad, do you have any closing remarks to make before we sign off?
I don't think so. We did do a paper, so there's a bit more information in the paper than was in the presentation. So if you want more details, you're welcome to look at the paper or contact one of us.
Fantastic. And if you are unable to get a hold of anybody's contact information, you could, of course, email the ICEA office at ICEA@ICEAonline.org, and we will be happy to connect you. And then I guess we will call this a webinar. Thank you, everybody, for tuning in. Thank you, Cheryl and Brad, for presenting for us today. Everybody have a fantastic rest of your week. Have a great rest of your day. Be good to each other. Be good to yourselves. And take care. Bye-bye.